Hello, my name is Keshwani. That's Keshwani, Keshwani. I have been solving math problems for GRE out of this book here, practicing to take the GRE General Test, the 10th edition. The problem that I'm about to solve is out of exam number 4. There are 7 exams in this book. I'm on exam number 4. Exam number 4, the very last problem of quantitative comparison, number 15. Number 15. Let's take a look at it. Alright. Number 15. The problem that I'm about to solve is the one that you're going to find on page number 280. Quantitative comparison, number 15. Since that's what I say every time in every clip, I had uncontrollable urge to say it like that. I don't know why. Don't ask me why. Alright, number 15. It's a hard question. It's a very difficult question, if you want to put it that way. Difficult, not in the sense that it involves complicated mathematics. That is never the case. In the entire exam, no question is difficult because it involves complicated mathematics. It does not involve, no questions involves calculus or analytical geometry or complicated statistics. Nothing like that. Differential equation, nothing like that. So then what makes a hard question hard? A hard question is hard because it involves some thinking that most people will not do. Out of carelessness, out of laziness, or out of a lack of thinking. If whatever you want to, however you want to put it, doesn't matter. The reason is immaterial. The point is, most people will not do the kind of thinking that is required here for whatever reason, and which is the reason why over 4/5 of the people who took this exam, 4/5 of them got this question wrong. Only 21% got it right. Let's take a look at it. We are told that x is more than 1, and we are also told that y is more than 1. I keep looking at the clock here because I'm going to solve this problem in 2 ways. There are 2 ways this problem can be done. One is what I call the classical way, the traditional way, the orthodox way, the geeky way, the nerdy way, the academic way, the proper way, the mathematical way, and the other one is what I call the intuitive way, the quick and dirty way, the unconventional way, the unorthodox way. I'm going to do the quick and dirty way first. And then if I have the time, I'm going to show you, for those of you who are curious, for those of you who are masochistic, I'm going to do the classical way. Okay? If you don't know what the word means, look it up and learn it. Particularly if you are one. Let's do the quick and dirty way first. We're told that x is more than 1 and y is more than 1. And then I'm asked to compare 1 over 1 plus x plus y, and here we have 1 over x plus 1 over y. Let's take a look at it. So the easiest and the simplest way to solve this problem is plug in number. Since x has to be more than 1 and y has to be more than 1, I'm going to put in 2 and 3. The common denominator is 6. The common denominator is 6. I'm not going to explain everything because otherwise I'm going to run out of time here. This is 6, so it's going to be 3 plus 2, it's going to be 5 over 6. And this is going to be, since this is the reciprocal, this is 1 over this entire quantity, is 1 over that, is the reciprocal of it. So here, if this is 5 over 6, this is going to be 6 over 5. And the answer, this is less than 1, this is more than 1, the answer is going to be A. If you were to plug in, if you were to plug in 4 and 5, 1 over 4 plus 1 over 5, the common denominator is going to be 20. This is going to be 5 and this is going to be 4. It's going to be 9 over 20 and this will be 20 over 9. And again, 20 over 9 is more than 1. This is less than 1. The answer again is A. It will seem, now here's the part, here's the tricky part. Now we are getting into the prickly area. Now it's going to get prickly. It would seem to most people, therefore, that the answer is A. The key here, there's a trick to solving this problem. The key here is this. I'm going to put it here so you can make a note of it. The key here is to ask yourself what happens if 2 In the problem like this, there is only there is one trick. I just gave you that trick. Most people do not know these tricks. I gave you that trick. You're getting these tricks. This is what I teach in my courses. This is just one. There are a bag full of tricks here. I cannot teach you obviously all because I can't give the whole game away. So I teach here and there just to whet your appetite. The trick here in a situation like this is to ask yourself what would happen if the two variables, or if there were more than two variables, if there were 3 or 4 or 5 variables. The question you would ask yourself is what would happen if all the variables were equal to each other? Because there is nowhere in this problem that tells me that x and y cannot be the same. There is nowhere in this problem that tells me that x and y have to be different. They do not tell me that x does not equal y. If they told me that x does not equal y, then of course I cannot make them equal to, obviously. Then that's their way of saying that they cannot be the same. In the problem it doesn't say that. Since it does not say that since it does not say in the problem that they have to be different, it does not say that they cannot be equal to each other, I make them equal to each other and see what happens, because that's where it's going to get kinky. So let's see what happens. If you keep putting different numbers, 2 and 3, 4 and 5, 6 and 7, you will always keep getting the answer A. What happens if they are equal to each other? Let's put it in here. I want to save some time for the classical work, so I'm going to pick up my speed here. If x is equal to y, which is equal to 2, why 2? I put down 2 casually without actually explaining. I gave the game away. Why 2? Because they're telling me that both x and y have to be more than 1. So the next logical number that comes to my mind for plugging in is 2. Let's just plug in 2, see what happens. If I plug in 2, this becomes half plus half, which is 1. This becomes half plus half, which is 1. And here I'll end up with half plus half, which is also 1. 1 over 1 is also 1. Voila! Now we have an answer of C. Before we were getting A. Now we have C, therefore the answer is D. And that's all it is. That was the only trick here. Making the two variables equal to each other. Now let me go to the back of the camera. If I have the time, I do want to solve it in the classical way to satisfy the curiosity of those people who want to see what's actually going on behind the scene, behind the curtains. Just give me a second. Oh boy. I am 8 minutes into it, so I'm going to have to do it fairly quickly. So here we go. I'm going to have to erase everything. And again, it's not, what I'm about to do is not meant for everybody. It's only for those people who are conversant in algebra, who are good in algebra, who can handle it, who can brook it, who can tolerate it, who can stomach it. Alright? And if you're not those people, just ignore it. So here we go. Oh, the classical way. The classical way, they tell me that this is 1 over x plus 1 over y. This is 1 over x plus 1 over y. If I take the common denominator, it's x times y, x plus y. And this is going to be the reciprocal, which is going to be x over y times x plus y. X over y and x plus y. If you make them equal to each other, which is the key here, as I told you before, you're asking yourself, is it possible that two quantities might be equal to each other? Because we can clearly see by plugging in that the one quantity is going to be bigger than the other. The question here is this: is it possible for the two columns to be equal to each other? So I'm going to make them equal to each other, and I'm going to ask myself, what does happen if I make them equal to each other? So let's see what happens. Now cross multiply. If you cross multiply on this side and this column, you end up equal to x and y squared, and here will end up equal to x plus y whole squared. That's all. That's all. We are done. X times x plus y times x plus y, because I'm cross multiplying it. And then that's it. We are done. Ask yourself, when is this possible? When is the sum of the two number going to equal to their product? Well, when two numbers are 2 and 2. 2 plus 2 equals 2 times 2. There you go. I left out one step in between. If x times y squared equals to x plus y whole square, then that also implies that x times y has to equal x plus y. That implies that x and y have to be 2 and 2. That's it. And when you put in 2 and 2 together, the two columns are going to be equal to each other. And that's your contradiction. You're looking for one contradiction, you found one. And since the answer is not always, the quantity in column A is not always equal, or quantity in column A is not always greater, because we found one instance when they are not. They are equal to each other, and therefore the answer is D. I hope you found it helpful. If you wish to get hold of me for personal private tutoring, face-to-face tutoring, go to my website at prep4gre.com and send me an email. All right? Thanks.